All right, here we go. So you have a sheet of paper out in front of you. Yes. Okay, and you have the some work shown for the warm-up. Some work shown. Okay, you can't put anything down in writing. You can't like display your thought process in writing. Okay, so we hopefully have diagrammed our thought process somewhere. Here's what I want you to do. We started there because I want to build off your thinking. It's not that you have to think differently. You're going to think the same. But the way we set this up is actually going to help you through this. So this is what it's called. It's called dimensional analysis. Here's the phrase right here. And we're going to work off this warm-up, right? Where we're converting grams, 425 grams, into kilograms. Before we actually do this, when would you want to do this? When would this be useful? Baking? Sure. Yeah. If you've ever looked up a recipe and the recipe came from somewhere that is not the United States, the recipe probably came in grams. And we typically use like cups and teaspoons. So we have to actually convert a lot in baking. Also in construction, if you build anything, you're going to do a lot of conversions. So that's exactly what we're doing. All we're doing is a conversion of units. We're taking a measured amount. In the example, our measured amount was 425 grams. And we're just converting it into the same amount, just in a different unit, right? Is our amount of flour in the bowl changing? No, it is not. It's just the unit I'm communicating in that's changing. Same thing with a tree. That's why there's a tree down here. If I measure this tree in inches and I go to the Kramer's nursery and I tell them about my tree, they're going to be like, I don't know what that means. Tell me the tree's height in meters. So if I convert my tree's height from inches to meters, has the tree's height changed? No, I'm just changing units. That's all we're doing. So that's all we're doing today with flour. That's all we're going to do today with jelly beans. Today we are dealing with jelly beans, and at the end of today, you're going to tell me how many jelly beans are in this jar. Okay, in dimensional analysis, we are just converting units. We are not changing amounts. Say that to somebody sitting around you, please. Okay. So, like I said, you can probably do this in your head. The goal is not actually to do these conversions right now. The goal is to be able to learn this strategy of dimensional analysis that will help you out as you go along. So when we set this up in dimensional analysis, we always set it up in the same format. So our format is we start with something that's measured. So we're going to talk about this bowl of flour. It's the flour that's in our bowl. If I make a different recipe, I'm going to measure out a different amount of flour. So the measured amount should be specific to whatever you're talking about. After we do that, we're going to multiply it by a conversion factor. And we'll talk about that in just a second. And then we're going to get an answer in the end. This is the format we always use. We always start with something measured times a conversion factor equals an answer. When you get tangled up in these problems, I want you to go back to this format. So go ahead and jot this format down, please. And then we'll walk through it in terms of the flour. We'll walk through it in another context. And then we're going to do it in terms of the jelly bean. But it says measured times conversion factor equals answer.
Has anybody guessed how many jelly beans there
I don't know if anyone's ever gotten it spot on, but people get close. Yeah, I do.
Did he count?
When I bought them, we actually sat down and counted them out.
What is it?
I will tell you at the end of class.
332.
She's gonna know because we did that.
Liam, you doubt me.
That's cheating.
Okay, moving on. Let's keep going. So, here's the premise of this. Whatever we measure it in, we're going to measure it in 425 grams. So that's our measured amount. We're measuring that in grams. In my answer, do I still want grams? No. What do I want my answer to be in? Kilograms. Right. So what I need to do mathematically is I need to get rid of grams and I need to get into kilograms. So that's what your conversion factor does. Your conversion factor gets you out of one unit and into the other unit. So what we do with the conversion factor is whatever unit is here, unit is on a measured number, I'm going to put on the bottom too. If I have grams on the top, I'm going to put grams on the next bottom of the fraction. Here's the premise. What is 4 over 4 equal to? 1. What is 0.37 over 0.37 equal to? 1. What is x over x? 1. Okay, what is grams over grams? 1. And that's the point. If I have grams on the top here and I have grams on the bottom, it's equal to 1. And so I can reduce grams out of the equation. That's how I get rid of a unit. If I have one unit on the top, the same unit on the bottom, I can get rid of that unit, which means the unit that I want to end in, your kilograms, you have to have on the top. So notice I've set the whole problem up and I've just put in my units. This is why it's called dimensional analysis. You're analyzing the problem using the dimensions. You're analyzing the whole problem in only units, and then you go back and you put in numbers. Okay, so what we really need to know now is our conversion factor. So anytime you use a conversion factor, it's always going to be a fraction. It's going to be equal or equivalent to 1. And you're going to have 2 units. Like kilograms and grams, I have 2 different units. Or jelly beans and milliliters, I have 2 different units. Okay, so the other thing about a conversion factor is that the top is going to be equal to the bottom. So we don't need just any amount of kilograms and grams. We need amounts that are equal to each other. Some of you may know this off the top of your head. If you don't know it, I have these little like quarter sheets of paper on every table, unless the class before you took them home with them because they loved them so much. And it should tell you the relationships between kilograms and grams. How many kilograms is equal to how many grams? So look at the sheet of paper or pull the information off the top of your head. Find kilo. Top equals bottom. How many kilograms is equal to how many grams?
1 kilogram is equal to... Oh, right there. 1,000.
1,000. Yeah. So 1,000 grams is equal to 1 kilogram. So that's what I'm going to put in to my conversion factor. If I'm holding 1 kilogram, Nico, and I'm holding 1,000 grams, those are the same amount. I'm holding the same amount in each hand, right? The top, 1 kilogram, is equal to the bottom, 1,000 grams. Is that a fraction? Are there 2 units? Is the top equal to the bottom? Yeah, so that means it's equal to 1 and I can use it. Okay, what you have here now, this is your whole equation written out. What you have here is we are multiplying fractions. This is not cross-multiplying proportions. This is multiplying fractions. Tell someone sitting next to you, this is multiplying fractions. Okay, so we're going to go 425 times 1 divided by 1,000, and what do I get? Yes. So is that the number that you got doing it your way initially? Mathematically, this is dimensional analysis. We can get to the answer multiple ways, but this is what dimensional analysis looks like. Okay, tell someone sitting next to you something familiar about this and a new idea that this brought up. What was new about this? Julian, what was new about this?
Something new?
Uh-huh.
Has to be the same on top as the bottom.
Oh, yes. Good detail. I like it. John, what was new about this?
Everything.
Everything? Starting with a measured number? You're going to get good at it right now. Yep. All right. Do you have this written down? Because I'm about to delete this screen. And this has your base set up and an example. Does everybody have this written down? I'll get out of your way if you want to take a picture. We have this written down. Or take a picture of the board. Yes, great. Gentlemen, we have it written down? Okay, great. Great, great. Okay. Now, I told you there were a couple benefits of doing dimensional analysis. Like I said, we're starting here with something that's super familiar. Once we get comfortable with dimensional analysis, we're moving into the unfamiliar. Right, Nico? Yes. Okay, one of the benefits is you can figure out the problem without understanding the concept. If you know how to do this, you don't have to understand the concept to solve this. Let me give you an example. Here is a number, 4.18 joules per gram degree Celsius. This is called the heat capacity of water. Has anyone studied heat capacity before? A couple people. Okay, if you have 75 grams of water and you want to raise that water, you're going to put it on a stovetop or a campfire, leave it in the sun. You want to raise the temperature of the water by 15 degrees Celsius. How much energy do you need?
More sticks.
Okay, give me a confidence rating. I could definitely do this problem right now. Okay, if you feel confident, go for it. Try it. If you don't feel confident, I'm going to show you how you can use dimensional analysis to solve this without understanding what heat capacity is. Are we ready? Ready for this? Okay, my question was, how much energy do I need? Right? So in dimensional analysis, we start with a unit. When I get an answer, what is the unit my answer will be in? Joules. Yeah. So here's your challenge. Use all the numbers. Get rid of grams. Get rid of degrees Celsius. And get me a number that has only joules attached. Using what we just did, using dimensional analysis. Try it. I'm going to give you 30 seconds. Try it. It doesn't matter. You don't have to understand it. Just get rid of grams, get rid of Celsius, and get me a number with just joules attached.
All right.
Okay.
Wait, can I use calculator?
Yeah.
Okay.
So remember I said if you want to get rid of a unit, you need one on top and one on bottom, right? So what we want to start with is the 418 joules per gram degree Celsius. I want to get rid of grams. So grams comes on the bottom. Where do I have to put the next grams? On the top or on the bottom?
Bottom.
It's already on the bottom.
Top.
Yeah, if I want to get rid of it, the other grams has to go on top. So I have grams on the top, grams on the bottom, and they reduce out. Okay, same thing with Celsius. I want to get rid of degrees Celsius. I have degrees Celsius on the bottom. Where does the next one have to go? On the top. 15 degrees Celsius. Notice I have Celsius on the top. I have Celsius on the bottom. They reduce out. What's the only unit I'm left with? Joules, which is the unit I want. So now we take out our calculator and we do 4.18
That's a nice calculator. Yep.
times 75
Yep.
times 15.
What'd you get, Christian?
Yep.
Tell me what you get.
4,002. Wait.
Wait,
4,700.
what?
4,700.
Okay, one more time. 4,702.5.
And 2.5.
Can anyone else verify?
Yes.
Nice. Yes. Yeah, so look at that. We just solved our problem and we didn't even have to understand the concept. Because dimensional analysis helps us work through it. This is the power of dimensional analysis. You're going to think it's a pain in the beginning because I'm going to make you do dimensional analysis on things you can do in your head. But the answer is not what I care about. It's the process. You have to learn the process because when I throw concepts at you, like a mole of molecules or heat capacity that we don't understand yet, the dimensional analysis will actually help you get to an understanding of the concept. Deal? Are you sold yet? Are you ready for this? Okay, we're going to do it with jelly beans today. So, like I said, you are going to figure out how many jelly beans are in this jar.
Can I count them?
Nope, because they don't come out anyway. They're stuck.
How do you remember how many jelly beans?
I have it written down.
Or she's cheating. She has why.
Okay, I'm going to hand you a sheet of paper. On the sheet of paper. Are you ready? Shh. Okay, on the sheet of paper, it's going to have some starting information. From that starting information, you have to figure out what your measured number is. Ooh. Okay, after you figure out what your measured number is, that's the first thing you're doing. The second thing you have to do is you have to come up with a conversion factor. You are making up your own conversion factor today. Has to be a fraction, 2 units. The top is equal to the bottom. It's equivalent to 1. The way you're going to figure that out is by thinking, what is the unit on the top? What is the unit on the bottom? The unit on the bottom should match the unit of your measured value. The unit on the top should match the unit of your answer. Okay? So this conversion factor, you're going to have to measure something about it. You could measure length with a ruler. You could measure volume with a graduated cylinder. That's in milliliters. You could measure mass with a scale. Make sure it's in grams. Okay, so you have to measure something in your conversion factor so that you end up with 2 units in here. And then in the end, I want to know the number of jelly beans in this jar. Liam, I know how many jelly beans are in here.
What if you miscount?
Ooh, good question. Better than that. Even better than that, I've already measured the jar for you. So I'm giving you the mass of the jar and the rings. And then I'm giving you the mass of the whole thing altogether.
Dude, cut it out.
Because you can find that yourself. All right, so I'm going to hand this out. You have the rest of the time to do this. When you are done, you're going to come tell me your number and I'll put it on the board so you can see how close to the actual value you are, which I definitely know.
Dude, I'll finish in like 2 seconds.
Liam.
What if you missed that? Sure, man. I'll know.
It's a possibility. Also, when you're done, I have some practice problems I want you to try. I'm going to clear the screen and show you my practice problems. Okay, your practice problem has to do with Mountain Dew. There's a whole bunch of things you can convert using dimensional analysis about Mr. Mig's Mountain Dew bottle. Okay, so when you're done, I'll have this up on the board, but I want your answer first. Any questions?
Why does Mr. Mig like?
No, he's famous.